Hello everyone! In this ROS2 tutorial, we explain how to establish an interface between a computer and Arduino by using a combination of ROS2 Humble, micro-ROS2 and micro-ROS2 Arduino library. This tutorial is extremely useful for students, robotics engineers, and ROS developers who want to implement ROS2 nodes on microcontrollers. For example, you can have ROS2 nodes directly running on microcontrollers, and these nodes can control motors or read sensor information. This information can then be transferred either to your PC computer or maybe to some other computer or microcomputer such as Raspberry Pi or, for example, NVIDIA Jetson Nano. Here, it's very important to emphasize that micro-ROS2 Arduino library does not support all the microcontroller boards. For example, this tutorial is based on Teensy board, and everything explained in this tutorial can easily be generalized and used in the case of popular ESP32 boards. If you go to the main GitHub page of micro-ROS2 Arduino library, and if you scroll down, you can see the list of all the supported boards. Here are the Teensy boards, and here's the ESP32 board. These are the officially supported boards, and here are the community supported boards. Consequently, if you have any of these boards, then you can use this library. The complete idea of this video is to teach you how to run a publisher node in Arduino and how to use micro-ROS2 agent and ROS2 Humble to receive the messages from the Arduino node and to display them on the computer screen. This can be seen as a Hello World program of computer Arduino interface. Over here, you can see an Arduino implementation of a micro-ROS2 publisher node that is uploaded to a Teensy board. This node will publish a message consisting of a continuously increasing integer number. The callback function is given over here. And over here, you can clearly see that we are increasing an integer number. On the other side of the communication link, that is over here, we have a micro-ROS2 agent running on my PC computer. Over here, you can see the messages that are being sent and displayed on the computer screen. We are directly listening to a topic that is used to communicate the messages. To demonstrate how this whole procedure works, I will reset my Teensy board, and this program will start from the beginning, and you will see on the left side what's happening. Currently the window is paused over here, and you will see that the data will again increase from 0, and here it is. This tutorial will actually teach you not only how to establish the ROS2 Arduino communication interface, but also how to install Arduino. More precisely, in this tutorial we explain: Number 1. How to install Arduino IDE in Linux from scratch. Then we explain how to install Teensy board in Arduino IDE. Then we explain how to install micro-ROS for Arduino library and how to install Teensy patch for micro-ROS Arduino library. Then we explain how to load the publisher example in Arduino Teensy, and finally, we explain how to run micro-ROS2 agent in ROS2 Humble that will display the messages sent from Arduino publisher on the computer screen. Here are the important notes. First of all, you have to carefully follow and understand every step we are performing. Otherwise, you will not be able to successfully run ROS2 nodes on Arduino or on the local computer. Also, we are using Ubuntu 22.04 and ROS2 Humble distribution. However, everything explained in this tutorial can be generalized to other distribution of ROS2. Also, a link to the manual explaining how to establish the communication is given below. Then, Although after small modifications, this tutorial can easily be changed such that it is applicable to other micro-ROS2 supported boards, we will also create a separate tutorial explaining how to establish a communication link in the case of ESP32 microcontrollers. The first step is to install Arduino IDE in Linux. To do that, go to Google and type download Arduino. Then go to the Arduino page, and over here you need to click on this file. I will click on just download, and over here just download. And the file should be downloaded in the downloads folder. Note that the downloads folder in Ubuntu system is located in home folder. This video is made in March 2024, and you can see that I downloaded Arduino 2.3.2. Most likely, if you're watching this video after March 2024, this version will be different. However, it doesn't matter. You can still use everything that I will explain in the sequel to install Arduino. However, it's very important to adjust the number, that is the version numbers, in the commands that I will type. The next step is to open a terminal. Click over here and open a terminal. Now, I will resize this terminal such that you can see what I'm typing and such that you can follow the manual given over here. Let's first go to the home folder. You can do it like this, where tilde is a shortcut for the home folder. Then let's create the Arduino folder. I created the Arduino folder in the home folder. However, you can also select any other folder. However, you need to modify everything that I will type in the sequel. Consequently, I strongly suggest that you install in the home folder and that you don't change the names. Okay, the next step is to copy the downloaded file from the downloads folder to our new folder Arduino. Okay, let's verify that the file is in the Arduino folder. Here it is. It's over here. Next, we need to install Fuse such that we can run the files without any problems. To do that, we need to first run this command, enter your password, and after that you need to execute this command. And as you can see over here, my Fuse is already installed on my machine. However, in your case you will see the installation progress. Okay, the next step is to add the executable permissions to our file. Namely, if you now type ls-la, you can see that we cannot execute this file. To set the proper permissions, we need to type this command. This +x means that we will set the executable permissions to this file. Now, if you type ls-la, we can see over here that we can execute this file. Next, attach the Teensy board to the computer or any other board you might be using. We need to set the permissions to the USB port such that we can upload the code from Arduino. Okay, so under the assumption that you attach your board to the computer, we can type this. And over here, we can see our port. This is precisely the port to which our board is attached. Now, I will type this command. Sudo usermod ag dialout and my username. Note over here that my username is Aleksandar, however, your username might be different. How can you find your username? Well, you can find your username by typing who am I, and you will see your username. Consequently, just type your username over here. Next, we need to type this command to set the proper permissions to our port. And let's see what's happening now. Good. We have all the permissions. Actually, not by running this command, we actually need to run this command. And we can see that we can read, write to our port. This is very important. To start Arduino, you can type this command, and the Arduino will open. Here it is. However, there is a more elegant approach for starting Arduino. Namely, if you use this approach, you will have to always open the terminal, and in that terminal you will have to execute that command. However, some users don't like it, including myself. So I will close Arduino, and let's create a shortcut. First of all, let's install gedit. Gedit is a very powerful program for editing files. Then let's go to this folder, and in this folder let's create this file. Here it is. This file will actually create a shortcut. You need to type this: desktop entry, type application, name Arduino IDE, and adjust your version, and here is the executable file. This is precisely the path to the file we use to start Arduino. You just need to set the proper file, and don't forget to adjust the version over here. Save this file, close the file, and now we can simply start Arduino by clicking over here and typing Arduino. And we can see the Arduino shortcut, and we can start Arduino. Good. Next, we explain how to install and use Teensy microcontrollers and boards in Arduino IDE and Linux Ubuntu. The idea is relatively simple. First of all, we need to go to this web page. This is the official download page of Teensy, and we need to copy this link. Then, let's go to Arduino. Then click on File, click on Preferences, and over here, paste the link. Again, you need to go to this web page, and you need to copy this link. Then, in Arduino, you need to go to Preferences, and over here you need to paste the link and click OK. Next, to properly use the Teensy board, we need to download another file. Go again to this web page, scroll down, and find this file, Linux UDEV rules. We need to download this file. To download this file, do the right click and save link as, and save it in the downloads folder. This is the file. Don't change anything, just click on save. Okay, next, go back to the terminal window, and you need to copy that file to the proper location. To do that, you need to execute this command. Here we are copying the file from the downloads folder, and here's the name of the file, to this folder. Press enter. Okay, let's now verify that the file is copied over there. We can do it like this. Then do ls-la, and here's the file. This is a very important step. Next, let's make sure that we can run a Hello World program in Arduino. So click over here and close Arduino, then start Arduino once again. Over here, you need to find the board. Click over here and click Select Other Board and Port and search for Teensy. Here it is. You need to find your Teensy version. In my case, I'm using Teensy 4.1. And click over here, click on OK. And over here, you need to click on Yes. Now be patient over here. You can see the compilation. It will take some time. And 1.59.0 is installed. This is very important. Okay, let's continue. Over here, I will simply paste a simple hello world program. Here in the setup function, I will start my serial. Then in the void loop function, I will simply print hello world, and that's it. Now, let's verify this code by compiling the sketch. After you press this button, you will see this Teensy window opening. Okay, this is very important, and let's upload the code. Okay, done uploading. So let's verify that everything is okay. Let's click on Tools, Serial Monitor, and here you will have an issue. Now, the issue over here is that you didn't select the proper port. You need to select this port, and here it is. Here's the Hello World program. I performed this setup process just to illustrate what happens if you don't properly set the port and the board. So it's always a good idea, first of all, to click over here to make sure that you're using Teensy, then click on Tools, then click on Port, make sure that this port is actually used, and finally make sure that the proper board is selected. And then you can actually easily upload the code and you will be able to run the code easily. As you can see over here, let's change this code a little bit to show you that this is actually working. Let's do this, upload the code, and you can see the serial monitor changed the message. Okay, this means that we have properly installed Teensy. Close Arduino and let's continue. You don't need to save this file. The next step is to learn how to install micro-ROS for Arduino library. However, before we do that, we need to download a patch that will enable us to use our Teensy board in micro-ROS. However, if you're using some other board, you don't need to download this patch. So what do we need to do? First of all, let's go to the home folder. And if you type ls-la, beside our main Arduino folder, which is given over here, you will see that we have two additional folders. We have this folder and we have this folder. For us, this folder is very important since Teensy is stored over here. I need to go to this particular subfolder inside of this folder. Consequently, I need to type this. Let me just go here and type. Now, if you are not sure where this folder is, or if you even have this folder, since this folder is 1.59.0 and this is precisely the Teensy version we have, you can simply go to this folder. That is, you can go one step back, and this folder should be the same for all Teensy versions, and you can simply type ls-la. And you can see the Teensy version is installed over here, or better to say Teensy Arduino version. So consequently, you need to type something like this. Okay, now we need to execute this command. We are using curl, and we are going to this GitHub page, and we are running curl with this file. Okay, after you do that, let's edit our platform file. And in the platform file over here, you need to specify your version. Now let's see over here what's happening. The version is 1.590. So here you need to type 1.59.0. This is very important, and save this file. Now, what did we achieve right now? Now we will be able to run our micro-ROS Arduino library with Teensy boards. And this is very important. The next step is to go to the GitHub page of micro-ROS for Arduino library. You need to go to this page. Then you need to download this library. However, first of all, you need to select the proper distribution of your ROS2. You need to select Humble, and this is very important since we are using Humble. And then you need to click over here and you can click on download the zip file. Then let's go to the downloads folder. Here it is, actually here it is. Then let's copy this file and let's paste this file in our Arduino folder. So go to Home, go to Arduino and paste this library. Or you can use a terminal window to copy this file. Okay. Next, we need to install this library in Arduino. So let's open Arduino. And we need to manually add this library. You need to click on Sketch, then Include Library, then click on Add Zip Library. And then go to the Arduino folder and click on the library and click on Open. And you can see over here, library installed. Now, let's go back to the Arduino folder. And over here, you can see a new folder is created. And in this folder, you can see micro-ROS library. So Arduino will store the libraries in Arduino folder under the folder library. Now, let's create a publisher node. I'm not going to write the publisher node manually since it will probably take me 1 hour to write the node. Instead, I will use the built-in examples. So click on File, click on Examples, and over here under Micro-ROS Arduino, find Micro-ROS Publisher. And here is the example. You can close the previous window and let me give you a few important comments about this example. So what's happening over here? This is a Micro-ROS Arduino node. This node will transmit an integer number as a message. What is important here to keep in mind? First of all, we don't use LED pin 13. However, the code still uses it since you want to blink it eventually. Now, what is here very important? Where do we create the nodes? Here it is. Micro-ROS Arduino node. This will be the name of the node, and this will be the name of the topic. And I will not go over this file since it will take me probably an hour to explain everything. However, the most important function over here is this timer callback. This callback function is used to actually increment the message. That is to increment the integer. Let's see this message.data. Let's go all the way up and we can see over here that we are using the messages of the type int32 and our message is int32 ROS2 data structure. Message.data, that is, this variable over here will be an integer and we can simply increment this integer. And then this is the implementation. You can spend some time to understand this code. If you're familiar with ROS2, you will not have problems to understand this code. Here's the void loop, and here's where we spin, and that's it. Now, let's learn how to compile and upload this code. First of all, again, I'm assuming that your Teensy board or any type board you're using is attached. Over here, first of all, select the board. Then you need to go on Tools, make sure that the port is properly selected. That is, we're using this port. And make sure that the board is selected. Now, first time you try to compile this code or to verify, you'll see probably an error, and I will explain you what's happening behind the scenes. Let's see. Now the sketch is being compiled. Now you have to be patient since it will take some time to compile the sketch. Again, let's be patient and you will see this. Now, you'll see these errors, right? Are these real errors or not? Well, I discovered if I press the reset button on my board, and when I press reset button, the LED will blink, and after I do that, and if I run verify again, I will be able to compile this code. And a lot of users have reported the same issue online. However, the proper solution is to simply press the reset button on your board and then upload. That's what you need to do every time you play with this board. This might not be the case for ESP32 boards, however, it might happen. Now, I noticed that my LED is actually blinking. This is because this code is also blinking LED, and you can see it over here. Okay, let's continue. Now, since the code is properly verified, I need to upload. So I will upload the code. And you will see here, done compiling and uploading. Let's wait a while, and you'll see done uploading. Congratulations! Now you're running micro-ROS2 node on your Teensy board. The procedure is same for the ESP32 boards. You will again have to use this publisher example and upload the code. Next, we need to learn how to run micro-ROS2 agent in ROS2 Humble that will display the messages sent from Arduino publisher on the computer screen. Let's go back to the terminal. And over here, I will open a new terminal in order to start everything from scratch. The first step when you're playing with ROS is to source the environment. That is, you need to execute this file setup.bash. Okay, next, let's go to the home folder and let's create a workspace folder in the home folder. I will call the workspace folder ws_test_micro-ROS. Then let's navigate to that folder and let's clone the micro-ROS2 file. To do that, I will run this command, and let's analyze what's written over here. Git clone, and over here I'm selecting the proper ROS distribution. In this case, this $ROS distro stands for Humble, and I'm going to this link. Here it is. You can also read the link over here and press enter. Okay, good. Let's continue. Let's make sure that we have the source folder. Here it is. The package is placed over here. And let's install ROSDEP by running this command. Enter your password. As you can see, in my case, ROSDEP is already installed. However, in your case, you will see the installation progress. Next, let's run update of everything. You will have to wait for a while, and let's make sure that all the dependencies are properly installed. This is also very important. Okay, next let's install pip. Okay, perfect, and let's build. These are standard ROS2 commands that are used to build packages and to build the workplace. Next, let's source the created packages. We need to source this file. This is a very important step. Next, let's create and build micro-ROS agent. To do that, we need to execute first this command, and after running this command, we need to run this command. And this will take a while. You have to be patient. Next, we need to perform one final sourcing of the created packages. That is, we need to source local underscore setup file. This is very important. Now we are ready to run the agent program. Okay, this is the most important command. What's happening over here? We are running micro-ROS agent. This is the package, and micro-ROS agent is the file. Then over here we need to set the serial, and we are specifying the serial over here. Okay, and let's press enter and let's see what will happen. Perfect. You'll see this output. See what will happen now if I press the reset button on my board. In the case if you're using some other board that's not Teensy 4.1, the procedure is similar. You need to press the reset button. Let's see what will happen. Error waiting for connection. Let's see, waiting for connection. Now the code is being started again, and you can see new things. Let's analyze. Session established, perfect. Participant created, perfect. Topic created, perfect. Publisher created, perfect. So we are creating actually an interface. Now our publisher node is running, and our computer is able to establish a serial communication link between the computer and the microcontroller. Okay, now let's see the commands, or actually let's see the messages that are being sent through the serial port. So what do we need to do? Let's open a new terminal while keeping this terminal running. This is very important since this agent has to run in the background. Click over here. Then again, you need to source the base environment. Not the package you just created, the base environment. This is very important. And after that, let's type this standard ROS command that will list the current topics. Okay, so let's see the topics. We can see this topic, very important. Here it is. Now let's go back to the Arduino file, and if you scroll all the way down, you will see it over here. Here it is, micro-ROS Arduino node publisher, and this is the topic that's used to communicate the messages. Next, let's see the list of nodes that are currently running. To do that, you need to type ROS2 node list, and we can see that we have a single node called micro-ROS Arduino node. Now, let's go back to our Arduino code, and here it is. Here is the micro-ROS Arduino node. That's it. Next, let's learn how to display the messages that are being sent. Note over here that due to the interest of brevity of this tutorial, I didn't write a subscriber node. You can easily modify this tutorial if you know micro-ROS2 to write a subscriber node. However, I don't need a subscriber node to be able to display the messages that are being sent through the proper topic. What I can do, I can simply echo the messages being sent. I can simply run ROS2 topic echo, and I can specify the topic name. And what will happen right now, I will echo the messages that are being sent through the topic. And I can see data, 251, 253. Now let's go back to the callback function. Here it is. Message.data is first of all initialized to 0. So where you can see that, let me find this part. Here it is. It's done over here. And this is actually setup function. So here initially, when you upload the code or when you reset the board, message.data will be initialized to 0. Then this callback function over here will increase the data. Okay, and that's precisely what's happening over here. To test this, let's reset our board. If I reset the board, you'll see over here something is happening. Programming, Teensy, okay, and you will see the data starts from 0. Perfect. This means that we restarted our code. Now, what is also interesting to observe over here is that once we press reset, let's see what will happen. Again, there is an error waiting for connection, and once the connection is being established, you can see that sessions is re-established. Okay, that's all for today.